Hi everyone, Lab Assistant here, and welcome to our lesson on Laws of Exponents. This video is going to be long because we are going to cover everything about the Laws of Exponents. And so what are you going to learn in this video? You are going to learn about all these different Laws of Exponents. You will learn about the product of powers, the quotient of powers, the power of a power, the power of a product, the power of a quotient, zero exponent, and negative exponents. The goal of this video is for a learner to be able to get a comprehensive reviewer for the laws of exponents if you are going to take board exams, licensure examination for teachers, praxis exams for teachers, or you are entering a university and you would like to review your laws of exponents, this is the video for you. Also, for those students who are just learning about the laws of exponents, this is a very good video also because we are going to provide a lot of examples. But before any example, we talk about the concept itself. So let's get started. Let's begin with the definition of exponent. According to ChatGPT, an exponent, also known as a power, is a mathematical notation used to represent repeated multiplication. For example, if you have 3 to the 4th, this 3 is what we call as the base. This small number to the upper right-hand side of the base is what we call as the exponent. And this 3 to the 4th means you multiply the base 4 times. So the exponent is the number of times you multiply the base by itself. Now, the first law of exponent says that if you have a number in exponential form written as a raised to x and another number written in exponential form a raised to y, you can find the product by simply copying the base and adding the respective exponents. Now, let's analyze this law of exponent number 1. Let's say we have 2 raised to the 5th. In expanded form, this is equal to 2 times 2 times 2 times 2 times 2. So we multiply the base 2 5 times. If you have another exponential number, let's say 2 to the 3rd, that is equal to 2 times 2 times 2. Now, if you want to multiply now, this 2 to the 5th times 2 to the 3rd, that is now the form a to the x times a to the y, where our a to the x is 2 to the 5th, our a to the y is 2 to the 3rd. Notice that the base a here, that means the base 2, are also equal, and the exponents are 5 and 3. According to this law of exponent, we will just copy the base 2 and we will add the exponent 5 plus 3 to get 8. But how does that happen? Notice now that this is the expansion of 2 to the 5th and this is also the expansion of 2 to the 3rd. If you are going to count how many times we multiply 2 by itself, there are 8 times. And so the shortcut way of multiplying 2 8 times is to write that in exponent as 2 raised to the 8. And we arrive at the 2 raised to the 8 by adding 5 plus 3. So that is the very important thing that a student must realize, that when you multiply exponential numbers with the same base, you copy the common base, but do not multiply the exponents. You only have to add the exponents. And that is the common mistake. I would like to emphasize this, that you are going to add this exponent 5 and 3 to get 8. Because this exponent just tells us how many times we are multiplying the base by itself. So let's have some application of this law of exponent number 1. Let's say we are given these 4 problems for our exercises. Let's begin with the first one. A to the 2nd times a to the 3rd. Applying law of exponent number 1, to get the product of these numbers in exponential form, we copy the common base and we add the exponent 2 plus 3 to get a to the 5th for our answer. So the answer for number 1 is a to the 5th. Let's go to problem number 2. 3b squared times 5b to the 7th. When there are numerical coefficients following our variables, you are going to multiply first all those numerical coefficients together, and then you multiply the variables that are the same. So that means you are going to apply the commutative property and associative property so that you can rearrange and regroup the factors. So here, notice that 3 and 5 are now written together like this. This is considered as one group. And the factors with variables b to the 2nd times b to the 7th are also put side by side because we are going to group them together. And this is the application of commutative and associative property. In the commutative property, you are allowed to interchange the order. In the associative property, we are allowed to regroup the factors of these algebraic expressions. So 3 times 5 equals 15. For b squared times b to the 7, that's when you now apply this law of exponent number 1 to get b to the 9th. So our final answer is 15 b to the 9th. Now let's go to problem number 3. Negative 4c to the 4th times 5c to the 4th. Again, we need to rearrange and regroup so that all numerical coefficients are together. All those factors with the same variables are also grouped together. So here, negative 4 times 5 is negative 20. C to the 4 times c to the 4th is c to the 8. So our answer is negative 20 c to the 8. And number 4 problem in law of exponent number 1, we have 5xy to the 4th times 6x to the 5th y to the 2nd. Again, let's rearrange and regroup. So 5 times 6 is 30. X times x to the 5th is x to the 6th now. Notice that x and x are together. Y and y are also together. So y to the 4 times y to the 4th is y to the 8th. So our final answer is 30 x to the 6th y to the 8th. Let's move to our law of exponent number 2. There are 3 cases that you are going to encounter for law of exponent number 2. But let's look at the law itself first. This is called as the quotient of powers. When we have numbers in exponential form, b to the x over b to the y, notice that the base are the same. To get the quotient, you just copy that common base and subtract the exponent of the numerator minus the exponent of the denominator. But there are 3 things that can happen here. Number 1 is when the exponent in the numerator is greater than the exponent in the denominator. Number 2 is when the 2 exponents are equal. And number 3 is when the exponent in the numerator is lesser than the exponent in the denominator. So let's look at the first case. Here is an example. 3 to the 7th, when expanded, is like this. Multiply the base 3 7 times. When we have 3 to the 5th, let's do the expansion also, and that is the expansion. We have the same bases here. If we subtract 3 to the 7th divided by 3 to the 5th, this is now what will happen. Notice that we have a 3 here and a 3 here that when divided will result to 1. And there are other more pairs of factors, one in the numerator and the same factor in the denominator that can be cancelled out because a number divided by itself is equal to 1. And therefore, what's left now would be this 3 times 3, which can be written as 3 squared. So what happened? From 3 to the 7th divided by 3 to the 5th to arrive at 3 to the 2nd, what we did was we subtract this exponent 7 minus 5 in order to get this exponent 2. So it now looks like that. And that is now what we mean by this law of exponent number 2. Now what happens if the 2 exponents are the same? So let's have an example. Again, 3 to the 7th and divide it by 3 to the 7th also. Notice that pair by pair, there's a factor in the numerator that is the same as another factor in the denominator, and when divided, they would result to 1. And so, what's the result here? The answer is 1. But if we continue applying this form that says copy the common base and subtract the exponent, then we will have also this form. 3 is copied and we subtract the exponent 7 minus 7, and that means this is equal to 3 to the 0. And the value of that we know is 1. This now gives us this definition of 0 exponent. Any number raised to 0 is equal to 1 because we can replace this 3 by any base. And when you divide a number by itself, that would always be equal to 1. But when you subtract the exponent of a number minus the same exponent, that would always result to a 0 exponent. Always remember this, any number raised to 0 equals 1. Now let's move to case number 3. In case number 3, what happens when the exponent in the numerator is lesser than the exponent in the denominator? Let's say we have 3 to the 3rd divided by 3 to the 7th. And this is how it looks like. Again, pair by pair, there's a factor in the numerator that is the same as another factor in the denominator, and when divided, that resulted to 1. And in this particular case, there are 3 pair of factors that we can cancel out. So 1 times 1 times 1, what's left in the numerator would be 1, and in the denominator, we have 3 raised to the 4th. Therefore, this is now written this way, 1 over 3 to the 4th. But again, if you are going to follow this formula, then this can be written as 3 raised to the exponent in the numerator minus the exponent in the denominator. And 3 minus 7 is equal to negative 4. So this becomes the base raised to negative 4. We now have here what we call as a negative exponent. And notice that this negative 4 becomes a positive 4 exponent if we write 1 as the numerator and we brought this entire exponential number down to the denominator. And that is always the case. When you have a number with negative exponent, you can always write 1 as the numerator and you can bring that exponential number with negative exponent down, but this time with positive exponent. So let's have some examples of this law of exponent number 2. So there are 3 cases, and here are the problems that we are going to solve. Let's begin with number 1. So 30a to the 8 b to the 3rd divided by 5a squared b squared. Now the first thing to do here is group together all the numerical coefficients. You have 30 divided by 5. Then group together all those factors with the same variables. So you have a and a here, and then b and b also. Then 30 divided by 5 is equal to 6. A to the 8 divided by a squared, we are now going to apply this law of exponent number 2. So that becomes a to the 8 minus 2. When the bases are the same, we copy the common base and we subtract the exponent 8 minus 2. That happens when we divide exponential numbers. And the third one would be b cubed divided by b squared becomes b raised to 3 minus 2. Then simplifying, this becomes 6 a to the 6th b to the 1st. When the exponent is 1, you don't have to write that anymore. It's already understood that the exponent here is 1. Let's have another example. Negative 7 c to the 8 d to the 5th divided by 28 c to the 10th d squared. Again, the first step is to line up all the numerical coefficients, line up those factors with the same variables. And then negative 7 divided by 28 is negative 1/4. C to the 8 divided by c to the 10th, that becomes c to the negative 2, following this formula. But we also said that this c raised to negative 2 can be brought down by writing 1 as the numerator and making this c raised to negative 2 becomes c to the positive 2. So it looks like that now. We don't have to write the 1 anymore here because 1 times this number is still the same number. Then d to the 5th divided by d squared is equal to d cubed because you have to subtract 5 minus 2 to get the exponent 3. Now when you have a negative 1 here, you can also put the negative sign before the fraction to look like this. And that is now our final answer. Let's go to number 3. 12x to the 8 y z to the 5th divided by negative 18 x to the 8 y to the 6th. So again, line up all the numerical coefficients, line up all those factors with the same variables. Notice that z is alone here because there's no z in the denominator. That's alright. Then the lowest term of 12 over negative 18 is 2 over negative 3. This x to the 8 divided by x to the 8 can be cancelled out. Or when you subtract 8 minus 8, that becomes 0, but any number raised to 0 is 1. And when you multiply 1 times all these other factors, it will not affect the product. So we just cancel it out. For y over y to the 6th, this becomes y to the 5th in the denominator. That is because you will have a negative exponent again. But the shortcut of doing this is if you saw that the exponent 6 is greater than the exponent 1 here, you just subtract 6 minus 1 to get 5, but make sure that you put the answer in the denominator because y to the 6th has higher exponent than y to the 1st. Then c to the 5th is copied. So for our final answer now, this is what we have. Again, when you have a negative here, you can also put the negative sign here. So that will look like this. Let's go to problem number 4. Here's our problem number 4. 2w to the 5th x to the 5th y to the 5th c squared divided by 7xy to the 5th c to the 5th. So again, the first step is to line up together all those factors with the same variables and also those that are constants. Then 2 over 7 can no longer be simplified, so we just copy 2 over 7. W to the 5th is alone, so we just copy W to the 5th. Then divide x to the 5th divided by x, that would result to x to the 4th. Y to the 5th divided by itself is 1, so we can cancel that out. And then c squared over c to the fifth. Notice that 5 is greater than 2, so the answer should be written in the denominator, and that is c to the third. As simple as that, we now have the answer. Now, let's proceed to law of exponent number 3. The law of exponent number 3 is also known as the power of a power rule. The form here is, you have a number in exponential form, b to the x, but that number is still raised to another exponent. So you have a power that is raised to another power. And the rule says, you just copy the common base b and multiply the exponent x and y to arrive at this. Now, let's take a look at some of the examples of this property number 3. Let's say we have 2 to the fourth. This is already in exponential form. And then we raise that also to another exponent 3. If we expand that, this means 2 to the fourth times 2 to the fourth times 2 to the fourth. Here, 2 to the fourth is our base, 3 is our exponent. And so we multiply the base 2 to the fourth 3 times. Now, if we go back to our law of exponent number 1, this 2 to the fourth means you multiply the base 2 4 times. This other 2 to the fourth means you multiply the base 2 4 times. The same thing with the last one. And there are how many 2's that we multiply all together? There are 12. So the shortcut way of writing this is to write an exponent 2 raised to the 12th. But without going through all these preliminary steps, we can also arrive at this exponent 12 by simply multiplying 4 times 3. And that is now the main concept for the power of a power rule of exponent. So that is the goal here. Avoid these extra steps from the given, go directly to the answer. And we do that by performing this computation in our head. We multiply the exponents 4 times 3 to get 2 to the 12. Now, the law of exponent number 4 is very similar to law of exponent number 3. So let's proceed to law of exponent number 4. And then we have applications that involve laws of exponent numbers 3 and 4 because they are very related to each other. The law of exponent number 4 is just the extension of the law of exponent number 3. The only thing that happened here is you have 2 factors in the base. And this one says, if you have 2 factors raised to a common exponent, then that is equivalent to getting the first factor and raise that to the exponent times the second factor raised to the same exponent. And the second case would now resemble law of exponent number 3 because you have a number in exponential form times a number in exponential form all raised to another exponent. And the way to simplify this is to apply law of exponent number 3 repeatedly. That means this first exponential number raised to this exponent y is equal to this, which is exactly our law of exponent number 3. Then another application of the same law of exponent is get this exponential number and raise it to y, and that is equal to b raised to xy, which is another application of law of exponent number 3. In other words, for law of exponent number 4, it's just we are applying law of exponent number 3 several times because there are 2 or more factors involved that's raised to an outside exponent. Now, let's concentrate on the first case. Let's say we have this example, the quantity AB raised to the third. Without knowing law of exponent number 4, our tendency is just to expand this using the definition of exponent. Then we rearrange applying the commutative and associative property to make it look like this. Then group together this 3a's multiplied by itself and this 3b's multiplied by itself. So this a times a times a is simply a to the third, and this b times b times b is b to the third. So if we don't want to go to this trouble of expanding this exponential number, how can we arrive at this answer by just looking at this given? That's easy. There's an exponent 1 here, there's an exponent 1 here. You just copy the base and multiply this 1 times 3 to get this 3. The same explanation for b to the third. And that is the direct application of this law of exponent number 4. Now let's go to case number 2. What if we have an exponential number that is multiplied by another exponential number and both of them are raised to another exponent? Here's an example. The quantity a cubed b to the fourth all raised to the second. So, going back again to the definition of exponent, this is its expansion. Then, if we rearrange them, that will look like this. Gather all together those factors with variable a and those factors with variable b, and then apply law of exponent number 1 copy the common base, and add their exponents. So this part here becomes a to the 6th. This part here becomes b to the 8th. We are adding the exponent 3 plus 3 to get 6, 4 plus 4 to get 8. Then again, the motivation is, from this given, how can we arrive at the answer without passing through the intermediate steps? And the answer is, you just multiply this 3 by the outside exponent 2 to get 6, multiply 4 and this 2 to get 8. And that is law of exponent number 4. Now let's have some applications of this law. Let's say this is the problem. The quantity 3x to the 4th y squared c to the 3rd all raised to the 2nd. So applying law of exponent number 4 and number 3, this is what will happen. The numerical coefficient has an implied exponent of 1, and that exponent 1 is multiplied by the outside exponent 2. That is what happened here. Next is x to the 4th has an exponent 4, and you multiply it to this outside exponent 2 to get 4 times 2, and just copy the base. The same thing happened for y squared, that becomes y to the 2nd times 2, and for z cubed, that becomes c to the 3rd times 2. That is applying this law of exponent number 3 and number 4. Then the rest is just simplification. 3 squared is 9, then multiply 4 times 2 to get 8, 2 times 2 to get 4, 3 times 2 to get 6. Copy the bases. Now the common problem here is many students tend to forget that this 3 should also be raised to the 2nd. They just copy the 3 and then perform the application of the laws of exponent for the variables. That's a common mistake. This numerical coefficient should also be raised to the same exponent. So that is now our answer for number 1. Let's go to number 2. Here we have some zero exponent, and let's see what happens. So again, apply law of exponent number 4 and law of exponent number 3. So this 4 raised to the 2nd is this part. This m to the 4th raised to the 2nd is that part. And do the same thing for the rest of the factors. Then let's simplify. This part here is equal to 16 because 4 times 4, that means 4 raised to the 2nd is 16. Then the next one is m to the 8th. Now any number raised to 0 is 1, but here if you multiply 0 times 2, that's also 0. So n to the 0 would still result to 1, and here is p to the 4th. And simplifying, this n to the 0 is 1, and this factor 1 would not affect the product of the remaining factors. So our final answer is 16 m to the 8th p to the 4th. That is now our final answer. Another problem. We now have here a negative exponent. So this is what we do. We apply the laws of exponents 3 and 4. Now this part here is raised to the 3rd. That's why we have this 2 to the 3rd. This y to the negative 1 raised to the 3rd becomes this. And the same explanation for the rest of all these factors. So one by one, factor by factor, we raise them to the 3rd. One common mistake here is to forget that these 2 must also be raised to the 3rd. Then, group together all those factors that are similar, meaning they have the same variables. Here, 2 to the 8 is equal to 8. This one, when simplified, is y to the 3rd. This one is c to the 6th. This is 8. The next is x to the 12th, and c to the negative 9. Then from here, let's apply the commutative and associative property of multiplication to group together all the constants and all those factors with the same variables. And from here, we can now apply law of exponent number 1 because you're multiplying the same. And from here, notice that 8 times 8 can be simplified. X is alone, so nothing can be done. Y is alone, so nothing can be done. But here, c to the 6 times c to the negative 9, we can apply law of exponent number 1. We have the same base, and we are going to add their exponents. So this is now the result. 8 times 8 is equal to 64. X to the 12 and y to the 3rd is copied. And 6 minus 9 is negative 3. So we now have here c to the negative 3 for the product of these two factors. When we have negative exponents, they can be brought down in the denominator. So finally, our answer would be 64x to the 12th over y to the 3rd, z to the 3rd. And this is now our final answer. And problem number 1 for your exercises. There's a timer here. So the answer is letter D. Next problem for your exercise. And the answer is letter A. You can always pause the video if you need more time. Here the answer is letter D. And for the next one, the answer is letter A. And number 5, the answer is letter A. Number 6, letter D. And number 7, the answer is letter A. And for problem number 8, the answer is letter B. Next problem. You can always pause the video if you find this too fast. And if your answer is different than our answers, you can always write that in our comment section. And let's see what happens. Why is there a difference between our answers? And finally, here is problem number 10. And the answer is letter B. Now, let's proceed to law of exponent number 5. So for law of exponent number 5, this is about the power of a quotient. If you have a fraction a over b, where the denominator is not equal to 0, and that is raised to an exponent x, then this law of exponent number 5 says you can split this into two exponential numbers. The numerator a is raised to the exponent x divided by another exponential number, b, raised to the same exponent. So from one number in exponential form with a fractional base, that becomes two numbers in exponential form. One is in the numerator and one is in the denominator. Let's have a demonstration on how this happens. Let's say if you have 2 over 5 raised to the third, this can be written as 2 to the 5th times 2 to the 5th times 2 to the 5th, applying the definition of exponents. You multiply the base 3 times. And when you multiply fractions, you multiply the numerators and you multiply the denominators. So multiplying 2 3 times is 2 to the third, and multiplying 5 3 times is 5 to the third. Now compare the results. Notice that we can also arrive at the answer without going through the definition of exponents by just getting the numerator and raising it to the exponent outside, and also copying the denominator and raising it to the exponent outside, and place that in the denominator. As simple as that. And that is exactly the meaning of this law of exponent number 5. But again, make sure that the denominator is not equal to 0. So here's an example. So here we're going to use a combination of two laws of exponent. One is the law of exponent number 5, and then the resulting numbers in exponential form still has to be simplified using law of exponent number 3. For the numerator, x to the third raised to the third becomes like this. For the denominator, it's like this. Then this is exactly the form of our power of a power rule, law of exponent number 3. So we multiply their exponents. 3 times 3 is equal to 9. 4 times 3 is equal to 12. And this is now our final answer. So two laws of exponents is applied here. Next problem. When you have this problem, 2x to the third y over 5x squared y to the third, all raised to the third, there could be two ways for you to do this. One is to apply immediately law of exponent number 5, but that is a longer method. The easier method is to simplify first the fraction by applying law of exponent number 2. It looks like this. Group together those factors that are constants and those with the same variables. Then simplify the expression inside this parenthesis, applying law of exponent number 2. So this looks like this. There's nothing we can do about 2 over 5, so we copy. X to the third divided by x to the second is x to the first. Y over y to the third is y raised to negative 2, or y to the positive 2 when written in the denominator, meaning 1 over y squared. Now, once this is already simplified like that, that's the time you apply law of exponent number 5. That way, this is much simpler than the previous one. So this one looks like this now. 2 to the third is equal to 8. Then x to 1 times 3 is x to the third. 5 to the third is 125. And y squared raised to the third. So you multiply 2 times 3 to get 6. And that is now our final answer. Now, on the other hand, if you apply law of exponent number 5 first and then you simplify, you will still arrive at the same answer. Only that it is much easier if you simplify first before applying law of exponent number 5, so that you avoid multiplication and then later on division again to simplify them. Next, you have this nested exponential number. We have negative 2 over 5 raised to the third. There's no problem here because a negative number raised to the third would still result to a negative number, and then all raised to the second. So how do we solve this? Applying law of exponent number 3, this will look like this. We copy the base and we multiply 3 times 2. And that is negative 2 over 5 all raised to the sixth. Notice now that we have an even exponent. So this negative number raised to an even exponent will become positive. So simplifying this now, applying law of exponent number 4, we can write this in 2 exponential numbers, one in the numerator and one in the denominator. Both are raised to exponent 6. Then negative 2 raised to the sixth is positive 64, and 5 to the power of 6 is 15,625. That is now our answer. Next problem. So when you have something like this, you know that we are going to simplify inside the parenthesis first before we raise to the second. So let's rewrite it this way. So 3 is alone, so just copy 3. X to the fifth divided by x to the third is x squared. Y squared divided by itself is 1, so no need for us to write that anymore. And c squared divided by c to the fourth is 1 over c squared. That's why it's now written in the denominator. Then copy the outside exponent 2. And from here, we can now apply law of exponent number 5 and law of exponent number 4. So this 3 is raised to the second. This x squared is raised to the second to get this. And then the denominator is c raised to 2 times 2, which is also another application of law of exponent number 3. Then simplifying, we get 3 squared equals 9. And x to the 2 times 2 is x to the fourth, c to the 2 times 2 is c to the fourth, and this is now our answer. Now, next problem. Now, when you have a negative exponent outside and you have a fraction, you can eliminate this negative exponent by getting the reciprocal of the base. So, what is the reciprocal of negative 3 over 5? That is negative 5 over 3. By getting the reciprocal, notice now that the exponent from negative 2 becomes positive 2. Then you have here a negative base raised to an even exponent. The result must be positive. So this becomes like this. When you have a negative fraction, it's either the negative is in the numerator or that negative could also be in the denominator, but not both. So we can take this negative to be part of this 5. So we have negative 5 raised to the second over 3 raised to the second. Notice that 3 is positive. Then negative 5 times negative 5 is 25, and 3 squared is 9. The common mistake here is you square 5 to get 25, you square 3 to get 9, and then you append the negative sign. That is wrong, because it will turn out that your answer would still be negative. But when a negative number is raised to an even exponent, the answer should be positive. And so that's our answer. This time, let's do some exercises for mastery of the laws of exponents. So we are going to apply all these different laws of exponents that we have learned so far, and there are 7 of them. From laws of exponent number 1 to number 5, then we have the zero exponent and the negative exponent. So here is our problem number 1. You can pause the video and try to attempt to solve this first. Now, for our answer, we are going to apply law of exponent number 1 here. So it will look like this. Copy the problem, apply law of exponent number 1, so we add the exponents 3 and 3, and simplify. The answer is letter D. Next problem. Again here, we are going to apply law of exponent number 1. So let's copy the problem. Now, when there are implied exponents, sometimes it's good to write them so you can easily see what the exponents are. Then rearrange so that 3 and 3 are together to get 9, and then p raised to 1 plus 2 is 3, so the answer is 9p to the third. Next example, here we have zero exponent, and these are the laws of exponents that we are going to apply. Copy the problem first. Now, let's deal with k raised to 0. That must be equal to 1, and all the other factors multiplied by 1 will not change its value, so just ignore that one. Then multiply this result. 2k to the first times 2k to the third is equal to 4k to the fourth. And so that is now our answer. And that is letter A. Next problem. 2p squared times 3p cubed. So again, multiply together all those constants and multiply together all those factors with the same variables. And this is now the result. So 2 times 3 is 6. P to the second times p to the third is p to the fifth. Common mistake here is to multiply 2 times 3. And you might think the answer is letter C. No, the answer must be letter D. Next problem. So let's copy the problem. That's the law of exponent that we are going to apply. 2 times 3 is 6. a to the third times a to the first is a to the fourth. So this is our answer. So here is the solution. Next problem. In this problem, we are going to apply these two laws of exponents. So let's copy the problem, but here there's an implied exponent of 1 for both of them. So I make sure that we understood that there is an implied exponent there. So this is one factor times another factor times another factor times another factor. This is an application of the law of exponent number 4. So each of the factors is raised to the outside exponent. So it looks like this. Now here, notice that you have a variable x and you have a variable x. You have a variable y and another variable y. So let's apply first law of exponent number 1. And it looks like that. And simplifying, you have x squared, y squared, all raised to the fourth. Now this form is you have product raised to an outside exponent, and that is law of exponent number 4. So that means each of the factors should be raised to the fourth, like that. And 2 times 4 is 8, 9 times 4 is 36. That is now our answer, and that is letter B. Next problem. So in here, we are going to apply these 4 laws of exponents. Let's copy the problem first. So for this part here, you have a product raised to an exponent. That is law of exponent number 4. And in here also, this is a product raised to another exponent, which is also law of exponent number 4. Let's apply that law. So this becomes the first factor raised to the fifth, the second factor raised to the same exponent. The same here. This is the first factor raised to the fifth and the second factor raised to the fifth. You have n to the fifth and you have n raised to negative 3 to the fifth. What we can do is simplify first this part here, simplify this, and simplify this, applying law of exponent number 3, which is this, and then you will still have n here and n there, and we can apply another law of exponent for that. So let's simplify first, applying law of exponent number 3. Negative 2 to the fifth is negative 32. Copy n to the fifth. 5 times 5 is 25, so you have m to the 25th. Negative 3 times 5 is negative 15. Then n to the fifth and n to the negative 15, they have the same basis. And the operation is multiplication. That means we can apply law of exponent number 1. So this would be the result. Copy the negative 32, n to the fifth times n to the 15th becomes now n to the fifth plus negative 15, and copy all the rest. Then let's simplify. Now you have a negative exponent here, so we are going to apply this transformation from negative exponent to positive exponent, meaning we can write n to negative 10 in the denominator, but that will become n raised to positive 10, like this. And we now have our final answer. So 4 different laws of exponents are applied in problem number 7. Let's go to the next problem. So here, notice that you have this expression raised to the 0. So we know immediately that this is equal to 1. And therefore, this is now what will happen. This is equal to 1. So what's left is 2m raised to negative 1. Then rewrite this in positive exponent, applying the definition of negative exponent. So our answer is 2 raised to m. And turn out this problem is easier. Problem number 9. So these are the different laws of exponent that we can apply. So first, let's copy the problem. Then apply law of exponent number 3 to multiply negative 3 times 3. Copy all the rest. Now y and y, they have the same base. We can apply law of exponent number 1. So that becomes y to the 8. So that becomes y to the negative 8. Now here, we have a negative exponent, which we can rewrite in positive exponent applying this. So what we now have is x to the fifth over y to the 8th, which is letter G. And finally, problem number 10. And here are the different laws of exponents that we can apply. Let's copy the problem first. This is a product raised to the second. We can apply law of exponent number 4. So let's implement that. Then simplifying, we now have this result. 1 times 2 is 2, negative 3 times 2 is negative 6, 2 times 2 is 4. Copy all the rest. Now you have x to the 6th and x to the 5th. We can apply law of exponent number 1 for that. The same thing for y to the 4th and y to the 1st. Then 4 times negative 2 is equal to negative 8, and simplify. But notice that you have here a negative exponent. So we are going to apply this law. And that becomes now 8y to the 5th over x to the 1st, or simply x. And the answer is letter A. Now, problem number 11. When you have a problem like this, even though this appears to be too complicated here, but the exponent is 0, we know that the entire thing is equal to 1. So for here, the answer is letter B. That is because any number raised to 0 is equal to 1. Next problem. These are the different laws of exponents that we're going to apply. So let's do this systematically. Copy the problem and simplify inside. So the numerator raised to the second, applying law of exponent number 4 becomes this. Apply also law of exponent number 4 for the denominator. Then simplify. Here, let's see if there are things that we can cancel. So notice that 2 squared is equal to 4. Then there is this negative sign here that we can now write here, negative 1. Then x to the 6th divided by x to the negative 4 is this part, and y squared divided by y to the negative 4 is this part. Copy the exponent. Then we now apply law of exponent number 2. Simplify this to get negative 4. 6 minus negative 4 becomes 10 is 10. 2 minus negative 4 becomes 6. And then copy the exponent 4. This is law of exponent number 4, this part here. You have a product. All these 3 factors should be raised to the 4th, like this. Then 4 raised to the negative 4 multiplied 4 times is equal to positive 256. 10 times 4 is 40, 6 times 4 is 24. And so our answer is letter B. Number 13. So here we're going to apply 4 different laws of exponents. Copy the problem. What can we do? Notice that in the denominator, this is the form of law of exponent number 4. So let's apply the law of exponent number 4. Each of the factors is raised to the outside exponent 2. Then simplify. Now group together those factors that have the same variables. Turn out y to the 6th and y to the 4th are those 2 factors. Then this x to the negative 4th can be written in positive exponent if we are going to put this in the numerator, applying this law. So this is now the result. We subtract 6 minus 4, applying law of exponent number 2, and 2 over 4 is simplified as 1/2. And simplifying, we now have y to the 4th, y squared, divided by 2, which is letter C. And next problem. This problem is easy again because you have this complicated base that is raised to 0, and any number raised to 0 is equal to 1. And so our answer here is letter A. And number 15, last problem. Here are the laws of exponents that we are going to apply. There are 4 of them. Let's copy the problem. Now notice that this denominator is law of exponent number 4. So we can apply it to look like this. Notice also that x and x are the same variables. Y and y are also the same variables. So that is an application of law of exponent number 1, which is this. Then the rest is simplification. Now you have a 0 exponent here, so it's an application of this. This is now what happened. Then you have a negative exponent here, which we can write in the numerator, which is an application of this. So the result would be like this. Notice that the negative 6 exponent is only for the y. It does not include the 4. So the 4 remains in the denominator. And so our answer is letter D. For more videos like this, please don't forget to like, subscribe, and follow us both in YouTube and Facebook. Our YouTube channel is at Math Avenue. The handle is at Math Avenue. And our Facebook page are Math Avenue, Assistant in German Academy, and Bicol Math Avenue. So thank you very much. This is Lando Assistant, and we hope you learned something in our video.